Okay, let's continue with the application of integration, which is area of a region, for the second part. Okay, so we have discussed the area of a region where you have only one curve, okay, and you have two lines and also the axis. So now we are going to discuss about area between two curves, okay, and we will start with the curves is about x-axis. Okay, so let's begin with the definition. So if fx and gx are continuous in the interval ab and gx is less than or equal to fx for all x in the interval ab, then the area of the region bounded by the curves y equal to fx and y equal to gx between the lines x equal to a and x equal to b is given by this formula. Okay, you will have area, okay, which is equal to the function will becomes, okay, the function will be the fx minus gx dx, and the limits is from a to b. So if you look at here, you have the gx is less than fx. Okay, how are you going to know? How do you know that gx is, this is the function, okay, how you know that g is less or greater than f? So we will see from the graph actually. Okay, so let's look at this example number 3. So find the area of region bounded by the curve y equal to x squared plus 2, okay, and the line y equal to 4 minus x. So here you don't have any, you have only one line, okay, it's a typo there, lines. You have one line and one curve. Okay, so the first step is to sketch the bounded region. Okay, if you look at, if you remember the formula just now, so you have the integration, the function that you need to integrate, and you have the limits of integration. Okay, from the question, we do not know yet the limits of the integration. Okay, and we do not know whether you need to which one is y and which y is g. Okay, so what you need to do is you need to draw the graph, the shaded region. You need to know the shaded region. Okay, so we have y equal to x squared plus 2. Okay, this is the x squared, okay, smiley face, but you have plus 2, so you will have something like this. So you have over here is 2. Okay, and another one is y equal to 4 minus x. So how are you going to sketch the graph of y equal to 4 minus x? One is sorry, you know that the y-intercept is 4, okay, which means that you have over here is 4. So you have a straight line which will meet the intercept is at 4. Okay, and here over here, what is the value over here? Okay, it's actually 4 also, right? Because here again we have y equal to 0, so you have 0 equal to 4 minus x, so x equal to 4, so over here is 4. Okay, all right, so we want to find the area which is bounded by the curve and the line. Okay, which means that you have this line, okay, and also this curve. So the intersection will be over here. So this will be the region. Okay, right. So now to find the area, you need to know the limits of integration, right? So we have the function, but we do not know what is the limit of integration. So what you need to do is to find these two values, A and B. The question now is, how are you going to find the values of A and B? Okay, so if you look at the graph there, okay, A and B is actually the intersection point between the curve and the line, right? So we have the line y equal to 4 minus x and the curve y equal to x squared plus 2. Okay, so now you need to, the intersection point is between the curve and also the line. So you need to set y equal to y, which means that you will have what? X squared plus 2 is equal to 4 minus x. Okay, so if you want to solve this, so you have x squared plus x minus 2 equal to 0. So we have what? X. So this one, right? Okay, so you have x equal to negative 2 and x equal to 1. So negative 2 will be the A value and 1 will be B value, right? So that one is the limits of integration. Okay, so you can have now the limits of integration is from negative 2 to 1, because we have over here. So this one, the graph is sorry, it's not up to there, so it's up to B only. Okay, here, so from negative 2 to 1. All right, so now you have we have two functions, right? X squared plus 2 and also 4 minus x. So just now you you need to have a greater function in front. Okay, how are you going to get, or how are you going to know which one is the larger function? Okay, right, so we have just now, this is the region. Okay, 4 minus x is actually, if you can see from okay, I just draw I draw a, what color I want to use. Okay, I draw a straight line which parallel to y-axis. So the curve will be smaller than the line. So that means that you will have the line minus the curve. Okay, the bigger one, okay, you need to subtract with the smaller one. Alright, so that's why we will have 4 minus x squared plus 2. And please be careful with the symbol minus here, because if you expand this, you will get 4 minus x squared minus 2. Okay, right? So actually this one you can integrate directly, no need to use tabular method, no need to use integration by parts or any complicated formula. Okay, so you can just integrate directly. Okay, and you will get there. So you will get negative x squared over 2 minus x cubed over 3, okay, plus 2x. Okay, because 4 minus 2 you get 2, so you integrate 2, you get 2x. So substitute with the upper and lower limits of integration, okay, which is 1 and negative 2, and you will get 9 over 2 unit squared, okay, as the area of the shaded region. Right? Okay, move to another example. So find the area of the region bounded by the curve y equal to x cubed and y equal to 4x. Okay, again, the solution, the first step is to sketch the bounded region. Okay, so we have y equal to x cubed, something like this. Okay, and then y equal to 4x. Y equal to 4x, something like this. Okay, so this is the shaded region. Okay, sorry, oops. Just draw this. Okay, so this is the shaded region. Alright, okay, so now okay, we need to know the lower and upper limits. Right, so you have two area actually. Okay, the first over here, you cannot combine it. Okay, because if you combine it, it will be different, the bigger, the larger, and also the smaller functions. Right, because okay, as I said just now, if you draw a straight line parallel to y-axis, so the green line will be bigger than the red line, the curve, um, the red curve. Okay, but if you go over here, so the red curve will be larger than the green line. Okay, so that's why you need to put into two parts. Okay, you have here as A and this one as B. Okay, but to get the intersection point, okay, you can just use the same as before, which is you have x cubed equal to 4x. Okay, simplify this. I have x cubed minus 4x equal to 0. So I have x squared minus 4 equal to 0. So I will have x minus 2, x plus 2 equal to 0. So my x will be 0, 2, and negative 2. Okay, so you look at here. So for the part A, so we'll have from negative 2 to 0. Okay, and the function will be x cubed minus 4x. Okay, because the red curve, which is x cubed, will be larger than the green line. Okay, and for part B, so this is part A and this is for part B. Okay, we integrate the function which is 4x minus x cubed. So 4x is the green line, okay, which is greater than the red curve. Okay, and the limits is from 0 to 2. So over here is actually 2. Right, combine it. You need to you need to add up this A and B, and you will get 8 units squared for the answer. Okay, so you can try this exercise later. Okay, 2 exercises for this part. All right, so let's move to the third part, which is area. Again, this is area between the curves, but this one is about y-axis. Okay, what are the difference between the previous example? So now if you have the function in terms of y, okay, so you will use this formula. If you still remember, just now we have both functions here is in terms of x, right? We have x cubed, we have 4 minus x, we have 4x. Okay, so in terms of x. But if you have in terms of y, so you will you will integrate in terms of y as well. Okay, So this is the example. Find the area of the region bounded by the curve y squared equal to 3 minus x and the line y equal to x minus 1. Okay, so how are you going to draw the graph for this question? Have curve y squared is equal to 3 minus x. So you can change this to x equal to what? Three minus y squared. So actually it's just the same as what you knew just now. Okay, if you have this one as x, this x, y, so minus y squared, okay, if you have minus x squared like this, right? So this is xy. But now it's if minus y squared, you have here. Okay, but you have 3, so you have like this. So this is 3. Okay, and then you have y equal to x minus 1. So how are you going to draw or to sketch the graph of y equal to x minus 1? Okay, another method is to plot. Okay, to plot it. Okay, how to plot? So we have the function y equal to x minus 1. So let x equal to 0. So what will happen? So you will have y equal to 0 minus 1, which is negative 1. So from here, you will get a point, a coordinate of 0, negative 1. Okay, 0, negative 1 is where? You have 0, negative 1. Is it over here or this one? So you need to know what is the value over here. So the value over here is by using this formula. Okay, x equal to 3 minus y squared. We know that over here is x equal to 0. Okay, but we do not know the value of y. So we have 0 equal to 3 minus y squared. So y squared equal to, y squared equal to 3, and then y equal to plus minus square root 3. So over here is minus 3. Okay, so negative 1 you have over here. Okay, another one is if you let y equal to 0, so what will happen? Okay, so you have 0 equal to x minus 1, so you will have x equal to 1. So the coordinate that you will get is 1, 0. Why 1, 0? Because we have x equal to 1, y equal to 0. So you need to read as x, y. Okay, so 1, 0 is where? This one. This is 1. Okay, x equal to 0. So you combine these two. So you get, sorry. Oh, hold on. Okay. Alright, so I combine this. Okay. So where's the shaded region? You think? So have the line here, also the curve. So this will be the shaded region. Okay. Right. Okay. So we have, okay, before we do we find the limits of integration, so we need to define which one is bigger. Okay, which function is bigger. So just now we draw a line which is parallel to y, but this one you need to draw a line which parallel to x-axis. So here, Okay, so the line here, okay, is smaller than the curve. So you will have the curve minus the line. Okay, and make sure all the functions are in terms of y. So this one you need to change lah to x equal to y plus 1. Okay, so to find the limits of integration here is by using or by equating the equation. Okay, have, where is the function just now? Okay, x equal to 3 minus y squared, so you have 3 minus y squared equal to y plus 1. Okay, so I solve this, I have plus 1 minus 2 equal to 0, so I will have y plus 2, 1 minus 1 equal to 0, so y is equal to negative 2 and y equal to 1. So that's why you will get the limits is from negative 2 to 1. Okay, and again this one is just a simple integration, simple function that you can integrate directly. Okay, simplify it and solve it, so you get 9 over 2 unit squared. Alright, so this is the last example for area, and this is the exercise that you need to solve. Alright, so that's all. Thank you.